Welcome to this episode of Mr. Layman's Knowledge Explosion. What I want you to take from this lesson are the main properties about the rhombus, a rectangle, and a square, which are all different types of parallelograms. So if you'll notice, under each of these definitions, I put down that they have all the same properties of a parallelogram. Because if you look at the definition, they each start with rhombus, a parallelogram with four congruent sides. Rectangle, a parallelogram with four right angles, and a square, a parallelogram with four congruent angles and four congruent sides. So what you need to understand is all the things we've talked about so far still exist and are still true for each of these shapes. But because of the more specific definition we're giving them, they're going to have more properties. So by the definition of rhombus, it says there are four congruent sides. So we know that all four of these sides could be marked congruent. Now I used a square to draw it on your notes. That doesn't necessarily mean you have right angles. So you might want to draw another example of a rhombus, which could be slanted, something like this, but would still have all four sides measuring exactly the same thing. Now because of that, you're going to get different properties, and one of them is that the diagonals are going to bisect the opposite angles. In a parallelogram, we learned that opposite angles were the same, so in a rhombus that's going to be true. But what this is saying is if you were to draw from one corner to the other, you're going to cut each of these angles directly in half of whatever that is. So if this whole angle was 100, this would be 50 and 50, or 80 and 80, 20 and 20, whatever that happens to be in that rhombus. And it works the same way for the opposite diagonal. So if I draw SU, again, you would be cutting this in half to say 40 and 40. And again, this has to match. 40 and 40 would be 80. 50 and 50 would be 100. The property of parallelogram still has to hold true, that those two add up to 180 degrees. The second unique property that you get with a rhombus is that the diagonals are perpendicular. So what that means is when I draw both of those diagonals, they're going to meet at exactly a 90-degree angle. So if I draw it on this other shape, you draw it, and even though I drew a very rough sketch of a rhombus, and those probably aren't exactly the same, you'll still notice that this looks very much like a right angle, and in every rhombus it is. So I want you to know that, and later I'm going to have you prove that in an assignment. So let's look at the properties of a rectangle. First, we start with the definition. A rectangle is again a parallelogram, but with four right angles. So by definition, we can go ahead and put on right angles at S, T, U, and V. That's it. Because those are right angles, I do get a couple things that happen. I still get the opposite sides congruent, but unlike the rhombus, I could have two sets of different sides. I'm still getting the opposite angles congruent, 90 and 90. I'm still getting the consecutive angles supplementary, 90 plus 90 is 180. But I get one more unique thing about a rectangle that I didn't have before with just a parallelogram. If I draw the diagonals SU and TV, those two diagonals are congruent. And this happens in every rectangle, that when you draw the two diagonals, they will be exactly the same. Again, this is something that I'm going to have you prove, so we will look at this in more detail later. For right now, I just want you to know that it is true. And the last one is square. Most people call all quadrilaterals squares and they think everything's a square, so just call it a square. But a square is so specific, it has very unique properties. For example, it is a parallelogram, but it has four congruent sides, so it's also a rhombus. And it has four right angles, so it's also a rectangle. A lot of times you'll hear people say the definition of square is a rectangle that's a rhombus at the same time. So instead of listing all these properties for you, I just noted a square will have all the properties of a parallelogram, and there are 5 of those. It will have the extra 2 properties of a rhombus, so there are 2 of those. The diagonals will bisect the opposite angles, and the diagonals will be perpendicular. And it's going to have that extra 1 property that a rectangle has, that the diagonals will be congruent. So if you were to mark all of that on a square, it would look something like this. All 4 sides are the same. All 4 angles are 90 degrees. When you draw the diagonals, those two diagonals, TV and SU, are equal. They're also bisected because it is a parallelogram. It's also bisecting these angles that are opposite from each other into, well, 45 and 45, because half of 90 is 45, and it's doing the same thing in this corner. So you see, just starting to mark some of these things, the picture gets very messy. But I want you to be able to know those properties and use them and apply them when you're looking for a missing measure on a square, a rectangle, or a rhombus. And we will look at some examples of proofs and how we use those properties to prove other things about other shapes. So let's take a look at the next page. And to practice knowing the properties, true-false really is the best way to do that. So I'm going to go through a couple examples of each, the rhombus, the rectangle, and the square, and then I want you to finish the rest and then work on the practice examples for yourself. So let's start with number one. If ABCD is a rhombus, then AB and BC are the same. Well, I know this to be true because all four sides are going to be the same when you tell me that it's a rhombus. So that's going to be true. For number two, if it says ABCD is a rhombus, then AB is congruent to DC. Well, that would have been true if it was just a parallelogram, and since a rhombus is a parallelogram, that's going to be true as well. And I could have also used the reasoning, well, all four sides are the same, so AB and DC, yes, that's true. If we jump down to number five, if ABCD is a rhombus, then angle ABC is a right angle, so I'm going from A to B to C. Does this have to be a right angle in a rhombus? No, it doesn't. This is going to be false. In a square, it has to be a right angle. In a rectangle, it has to be a right angle. But by definition, a rhombus does not have to have a right angle over there. So this is not true. So that's where you have to be careful and pay very close attention to what words you are given. So when we switch and we go to number 7, if ABCD is a rectangle, then is AB congruent to DC? Well, this is true because the opposite sides of a parallelogram are congruent, and a rectangle is a parallelogram, so this is true. If ABCD is a rectangle, number 9, then angle 1 is congruent to angle 5. Now, I do know for a fact that angle 1 is congruent to angle 6 because those are alternate interior and the lines are parallel. In a rhombus, all four of these angles across from each other would be the same. But I was given that this is a rectangle, and in a rectangle I don't know that the diagonals are bisecting that into two congruent pieces. So for a rectangle I have to say that's false. For a rhombus I would have said true. Number 12, if ABCD is a square, then AB is congruent to DC. Well, just like a rectangle, those opposite sides are going to be the same, so that's true. Number 14, if ABCD is a square, then angle 1 is congruent to angle 5. Now here it's different. Again, angle 1 has to be congruent to angle 6, but a square has all the properties of a rhombus. So angle 6 is the same as angle 5, and angle 1 and angle 2 are the same, because in a rhombus that diagonal's cutting that opposite angle into two congruent pieces. So in this case, angle 1, 2, 5, and 6 in a square will all be the same. So I could say that this is true for a square, whereas for a rectangle, I had to say that it was false. That's how you want to reason through these true or false questions and learn the properties. So do the rest of these true-false, work through your practice examples, and see me if you have any questions. Good luck.